Alrighty, here we go. I thought I'd get this done pretty quick here. So we're going to look at a few more different types of trig equations, okay? Hold on, I'm just going to go ahead and grab my calculator. Here it is. So the first question that you might be concerned about is something like this. Okay, sine x is equal to 0.6324. Now, I'm pretty confident that a lot of you know what you need to do with this, right? You go sine -1 of 0.6324, and then you can give me an answer. However, what you might not be aware of fully is that you can do this in both degrees and radians, okay? So you got to make sure that you understand what it is that you're doing. I would choose to do it in radians because that's kind of the thing that we're doing right now. So notice that we're in radians here. So I'm just going to go enter. That's okay. Clear it out. Now I'm going to go second sine of 0.6324, and that gives me 0.684, which means this is 0.684 rads, or I've rounded up to 685 radians. Okay, you have to understand that this is radians. Okay, guys, if I did it in degrees, right? So I'd have to go to mode, I'd put it down, go to degrees, and then I'd clear it out and I'd go second sine 0.6324, and you get 39 degrees or 40 degrees. Okay, so depending on which you do, so let's do this, let me write down both right now, 39.2 degrees. Okay, but what I'm going to do is I'm going to put it back in radians because that's what I'm going to really use, but I just want to show you how they both kind of work. Okay, so now you know that your angle is 39.2 degrees, right? So if you look at the situation here, all sine, tan, cos, right? This is 39 degrees, or it's also 0.685 rads. So your solution is 0.685 rads, or 39.2 degrees. That's one solution. How do you find your other solution where it's not any different than what you've done before? Okay, we were just using special angle triangles that we knew, like 30 degrees, 45 degrees, or 60 degrees, but now we're using not abstract, but random degrees and radians, okay? But do the same thing, meaning if this is your reference angle, which it always is when you find, then you do this second sine thing, you always get your reference angle, okay? That means that reference angle is over here too, because that's the positive sine quadrant. So we have 39.2 degrees here. So what you do is you either go 180 minus 39.2, that means it's also going to give you 140.8 degrees, or you can do pi minus that 0.685, and you end up with 2.457, okay, or 2.457 rads. That's how we do these questions when you've got a decimal here, all right? No different, just not using special angles, basically, okay? So let's have a look at the next one. Start this one off, give it a shot. I will be there momentarily. Right, so we need to do something to this first. We need to go tan x is equal to 1 over that, right? So we're going to go 1 divided by 1.1482, so 0.0871, let's say, 0.871. So negative 0.871. Now, what you need to do now is tan -1 of negative 0.871. What I'd like you to be aware of too is if I want to second tan this, I don't have to round it off. Just go second tan of that answer. Okay, so we get 0.717 rads. So x is equal to, hold on, let me just use it on this. So x is equal to, what did we get? 0.7165, let's say. 0.7165 rads. Now again, if you wanted it in degrees, remember I'm in radians, okay? If you want it in degrees, then change it to degrees. So my other solution, hopefully we can see, well maybe that's not even my first, this is my reference angle. Sorry guys, this is the reference angle, because don't forget you need a negative, right? So all sine, tan, cos. So we're looking at a reference angle in here and in here, where this is 0.7165, this is 0.7165. So this angle here would be pi minus, so we're going to go pi minus 0.7165, and you get an angle of 2.43. So x is equal to 2.43, right? And I'm going to get another x right here, which is going to be 2 pi minus that, right? So 2 pi minus 0.7165, and you end up with 5.57, let's say, and 5.57, and there you have it as far as your two solutions go within one revolution, right? Now you can see that these are probably pi away, 3.14, pretty much exactly. So if you wanted to write down a general solution, right, you can start off with the first one, 2.43 radians, and it occurs every pi, so plus pi n would be your general solution, where n is an element of integers. And there you go, off to the races, okay? We're going to take this a little bit further now. We're going to be looking at a different situation, folks, and this is kind of the next step, the evolution in solving equations, right? We've got a 2x here. Makes it a little trickier, but let's just think of it as a theta, okay? So you can actually think of it as sine theta is root 3 over 2. And then we solve this. Well, if I look at a special angle triangle, right, I can go like this. 1, 2, root 3, that's 60 degrees. So you can see that theta here will be an all sine tan cos, right? You have theta is equal to, let's say, 60 degrees. Yeah, let's use degrees in this case just to make it easier, okay? So equal to 60 degrees. Hopefully you can see if you want it to be positive, it occurs over here as well. If that's a 60-degree reference angle, it's going to be 120 degrees as well. So this is your solution right now, okay? This is your solution if it's theta. But what you have here is theta being 2x. So remember that you have 2 revolutions now in 2 pi. So this is a little tricky here, guys, okay? So what you have is over the interval, okay, over 0 less than or equal to theta less than or equal to 2 pi. You have 2x is equal to 60 degrees, which means that 1x is equal to 30 degrees. You also have 2x is equal to 120 degrees, which means x is equal to 60 degrees. So what you have to understand here now is that you've kind of increased your period, right? So it used to be that let's say this was 2 pi, right? Let's say that's 2 pi. It used to be like this. So when it's equal to root 3 over 2, you only hit it twice. Boom, boom, right? Over 2 pi. But now what happens is you have actually 2 cycles in 2 pi. So it means you hit it here and here, which is half of that, and that's half of that. But then you also hit it here again. And what you notice is that you've changed your period, right? Your period now is not 360, but 180 degrees. So this occurs every 180 degrees. So 30 plus 180 is 110 degrees. Plus another 180 would be, what would it be? 290. No, that's not right. 100. That's 210. So 210 degrees. So look at this. If I go 30 plus 180, I get I did times. 30 plus 180, I get 210. That's still within my 360. If I add another 180 degrees, I'm beyond my 360. So these are the only 2 answers, right? Now, x is 60 here. If I add another 180 degrees, it's going to be 240 degrees. So these end up being all my answers, okay? And it's because you've doubled the frequency, or you have now 2 periods within that 2 pi, which means you double the amount of solutions that you had, right? Now think about this. If I had sine 3x, I would triple the amount of solutions, so I'd have 3 pairs of numbers, and the period again would be adjusted accordingly as well. All right, so that is kind of the next step, the evolution of these type of questions. Let's try another one. See if you can rearrange this first of all before we continue. All right. So negative 1/2, hopefully you can see again that that's a 30-degree angle, degree difference angle. So what we're looking at, a negative 1/2, so all sine, tan, cos, it means it has to occur down here. So 30 degrees and 30 degrees. That is our reference angle. Let's use now solutions, or sorry, radians. Okay, so pi over 6. So in this case, my 3 theta is equal to pi over plus pi over 6. So it's 7 pi over 6, and it's also equal to 11 pi over 6, right? So this is 7 pi over 6, that's 11 pi over 6. My 3 theta is equal to that. If you write it out this way, then what about your theta? Your theta, therefore, will equal 7 pi over 18, right? 7 pi over 18. And this one will be 11 pi over 18. But now, since let me draw this again for you, okay? Since we originally had 30 degrees, right? Boom, and then, sorry, -1, so boom and boom, we're looking at negative 1/2. That's where it used to be, right? 2 solutions. That's these right here. But what happens now is that you have 3 revolutions. So 1, 2, 3, 4, 5, 6. There are 6 solutions. And what you have to understand is that you've changed your period. Okay, you've changed your period. Your period now is going to be 2 pi over 3. Okay, this is your period. So if you wanted an 18th, right, an 18th, so times it by 6, times it by 6. So your period is also 12 pi over 18. So what you do is you go 7 pi over 18. And then you add 12 pi, so it's 19 pi over 18. And then you add another 12 pi, which is 31 pi over 18. And these are the 3 solutions that come from this. Okay? And then similarly from this one, 11 pi over 18. So we're going to have 11 pi over 18. And I'm going to add 12 pi over 18, which gives me 23 pi over 18. And then I'm going to add another 12 pi over 18, which gives me 35 pi over 18. And you can see that 2 pi would be 36 pi over 18. So that's all I have. Those are my final solutions, ladies and gentlemen, for that situation. I know these seem a little funky, but I'm pretty confident that with a little bit of effort, you're going to be able to sort these out. Okay, I got one last one I think might be relevant for us to do. Let's give it a shot. It'll get a fresh sheet of paper. No, it won't. I'm going to use this piece of paper. So sine squared, sine x, boom. Let's make an equation here. 6x squared minus x minus 1. Well, you could probably factor this on your own. You don't really need me. 3x, 2x, right? Let's go 1 and 1. It's going to be a minus 3 and a plus 2. So here we go. So we're going to factor this thing out, first of all, into 3 sine of 2x, right? Plus 1. And then we're going to go 2 sine 2x minus 1, and that's all equal to 0. Okay, so that's how we have to start. We have to be somewhat comfortable writing that out. 2 sine 2x minus 1, 3 sine 2, yeah, okay. And now we look at each of these separately, right? So let's rearrange this one. Sine 2x is going to equal negative 1/3. I have to solve this. This one here, sine 2x is equal to 1/2. We have to solve that one. All right, so let's deal with this one a little bit first, because we can see hopefully that is a 30, 60, 90. So 1, 2, root 3, right? 30 degrees. Boom, we're looking for positive. So all sine, we're looking at that one and that one. So in this case, 2x is equal to pi over 6 and 5 pi over 6, which means that x is equal to pi over 12. And in this case, we're going to get 2 with that one, and then it's 5 pi over 12, right? Your new period for that, right, is pi. because it's got a 2 here, so 2 pi over 2, your new period is pi for both of them, right? So that's your new period, pi, very important that you got that, which is equal to 12 pi over 12, because that kind of helps me out here, right? Now if I add 12 pi over 12, I get 13 pi over 12. And if I add 12 pi over here, I get 17 pi over 12. And those are my 4 answers that you're going to get from that first situation, right? So pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. There you go. So now, special angle triangles. Look at this side here. That's not a special triangle. I don't care what you say, that's not a special angle triangle. So what you do is you do what we did before. This isn't a decimal, but it's a fraction. It's the same as what we did up here, except instead of a decimal, we're using a fraction. So it's sine -1 of, let's just use the positive, remember, to get the reference angle, right? And that's going to equal my 2x. So second sine of 1 divided by 3 gives me 0.3398. So 2x is equal to 0.3398, right? And if we look at all sine, tan, cos, right? I'm looking for a negative now, all sine. So down here and down here. So this is 0.3398. This is 0.3398, right? And so what we do is we add pi, right? So pi plus 0.3398 is 3.48. That gives me this one here. So 2x is equal to 3.48. And then I have another one, 2x is equal to 2 pi minus 0.3398. So 2 pi minus 0.3398, and you get 5.94. Okay, 5.94. But this is that double angle thing, right? So yeah, it works. But what you've got is 2 revolutions, remember? So that means that x is equal to 3.48 divided by 2, which is 1.74. Okay, and in this case, you get 5.94 divided by 2. So you get 2.97. Well, now you know that you've doubled the amount of solutions because you halved the period, or you have the period, so you have 2 revolutions. Your new period was pi, which is 3.14. So if you want to find another one, it's 1.74 plus pi. Boom, 4.88 would be another solution, right? And then 2.97 plus pi would be another solution, 6.11. Now if you added another pi, 4.88 plus pi, you're past 6.28, so you're beyond your 0 to 2 pi, right? So all we've really done here is found our solutions between 0 and 2 pi. If you wanted to find your general solutions, we can do that as well. But I think we're going to leave it at that, folks. That's a lot of stuff. Hopefully you made some sense out of that. If not, we'll sort it out in class, I'm sure. Thank you. Come again.